Machine learning is a term that we use to describe techniques that allow a computer system to learn from data that we put into it. So a classic example would be designing some kind of spam filter for email messages. If you want to design a spam filter the classic way, you're going to have to come up with a large set of rules that specify exactly what counts as spam and what doesn't count as spam. And that can be very difficult because there is a very large variety in emails. If, on the other hand, your spam filter is based on machine learning, what you'll be able to do is say, well, here's a load of spam emails, this is what they look like, please make sure that things like this do not get into my mailbox. So the computer program is able to learn from examples that you give it, rather than relying on pre-programmed instructions to perform the task. This type of machine learning, by the way, is called supervised learning. So supervised learning means a computer system is learning from examples we give it. In this video, we'll be discussing a very simple, very easy to understand type of supervised learning, which is the k-nearest neighbor classifier, or simply KNN classifier. So before we begin, let me explain two terms that I'm going to be using quite a lot in this video, which are examples and queries. Examples, I mean this makes perfect sense, are the actual example items that the program learns from. So in case of our spam filter example, these are lots of spam emails and normal emails of which we already know what they are. And then queries are actually new items that have not been classified yet. So this would be a new email that comes in and we want to know if it's spam or not spam. Okay, so this is the actual work that needs to be done. And actually let's keep using the spam or not spam example because I quite like it. So first of all, example data. What does the incoming example data actually look like? Well, you could see it as a table, where each row in our table is an instance of example data. In our case, every row in the table would be an email message. Every column in the table would be a property or a so-called feature. So feature 1 might be how long is the email, how many words does it have. Feature 2 might be how many paragraphs does it have. Feature 3 might be how many times does this specific word occur in it. Feature 4 might be how many times does this spelling mistake occur in it. All these kinds of properties you might come up with of a certain email message. What exactly they are doesn't really matter for now. All that we need to know is that the rows in our table are the examples and the columns are their properties or their features. For now, let's consider a really simple situation where we are only looking at 10 examples and only 2 features. Now we could also look at this data in a much more graphical way. So instead of saying, well, we've got a table with a load of rows and columns, we could say, well, the first column, the first feature, which I believe was the amount of words, is the y-axis in a graph. And the second column, the second feature, which is, I believe, how many paragraphs are in the email, would be the y-axis. What we can now say is that every one of our examples, every one of our example emails becomes a certain location, a certain point on this two-dimensional plane. And now we're essentially ready to start classifying queries. So let's say a query comes in, a new email, we don't know what it is, and we measure how many words it has, so this is its value for column 1 or for X, and we measure how many paragraphs it has, which becomes its value for Y, and so the query also becomes a certain point somewhere in this space. What we then do is we take a look at the nearest neighbours of the query. This is why it's called k nearest neighbours. K is the amount of nearest neighbours we look at. So we could look at the 3 nearest neighbours, or the 4 or 5 nearest neighbours of our query, depends on our choices. So let's say we look at the 3 nearest neighbours in our training examples to our query. And what we can then see is that 2 of those, for example, are spam, and 1 of them isn't spam, because remember, of these training examples we know if they're spam or not, because they've been labelled. What we can then say is, well, most of the nearest neighbours of our query are spam, Therefore our query is probably also spam, and now we classify it as a spam email. This is what KNN does, so it's actually pretty straightforward. Now of course clever people amongst you will have noticed that first of all we're using very few examples, we're only using 10 examples, and then also we're only using 2 features, 2 dimensions if you will, which is never going to be near enough to actually classify spam email. If we want to properly classify email messages, we're going to need a lot more examples and also a lot more features. Having a lot more features means that our space is going to have a lot more dimensions. The fact that we humans can't imagine what a 50-dimensional space looks like doesn't really matter, because the only thing that we are essentially doing is calculating distances between points and making decisions based on those distances. And we can calculate distances between points in any number of dimensions. Even though we might not be able to see what it looks like, the maths works out just fine. So now that we know what KNN does, I thought I'd actually make an example and program up a little KNN classifier myself so I can show you what it does. And what my classifier is going to do is it's going to predict a YouTube channel's Social Blade rank. So in case you don't know what a Social Blade rank is, there is a website which is called Social Blade, which you can use to view statistics of YouTube channels. Now, not only can you view the statistics on this site, the site also gives your channel a certain rank. So for example, it gives this channel a C+, and it gives PewDiePie an A. And this rank is based on statistics. It's based on how many subscribers and views and statistics about your channel. But no one really knows how this rank is computed. So obviously Social Blade knows how to compute it because they compute it, but no one exactly knows how this rank is created from the statistics. So this is where a KNN classifier could work. So what this classifier is going to do is take in as its example data lots of statistics from several YouTube channels, 33 to be precise, with the corresponding Social Blade rank as the label, and then what we'll be able to do is fill in the statistics of any YouTube channel of which we don't know what the rank is, and then the program will be able to predict what the rank is based on the examples that it's seen. Now that we're at the computer, let's start by taking a look at our example data. Now the example data is contained in 2 files, a text file and an Excel worksheet called data. Now this worksheet contains a 33 by 5 table, so it's got 33 rows and 5 columns. Every row in this table represents a YouTube channel, an example channel, and every column represents a certain feature of a channel. So the first column is the number of subscribers, the second column is the number of views, the third column is the number of videos they have uploaded, the fourth column is the amount of views gained over the last month, and the fourth column is the amount of subscribers gained over the last month. And of course in this one negative values are also allowed. Then in this text file we've got the corresponding ranks for all these channels. So for example, row 11 in here is PewDiePie. So you see here it's got 101 million subscribers, which corresponds to this A in our label list. So PewDiePie apparently has Social Blade rank A. All of this data is going to be imported by our KNN classifier, which I wrote using C#. Now I'm not going to go through all this code in detail in this video because it's not a programming tutorial, but what I will do is I'll put this code on the AKIO TV website so that you can take a closer look at it if you want to. And basically what this is it's exactly what we've just discussed. Okay, so this is doing exactly what I've just explained. So it's going to take in all of this training data, all of these examples, and then it's also going to take in a certain query that we have to type into it, and then it's going to predict what the Social Blade rank of that query is. Alright then, so let's give it a test. Now of course I can't use my own channel, because my own channel is actually in the data set. Line 4 in the training set is my own channel, so we can't use this because then of course it'll get the right answer because it's already seen this one. So let's use DSLR Guide, for example. Very nice channel. Social Blade gives it a B. I think it deserves better, but, you know, this is what it gets. This is what our program should also output. Because, again, our program is not made to properly rank things. It's made to rank things the way Social Blade does. So we're going to go to our program here, and we're just going to type in the data that it asks for. Alright, so we're going to type in this case, 873K, and then we're going to say 2,000 subscribers last month. Now I'm going to press enter, and you can see here the most likely SB score for this query is B. So the program made the right prediction that this channel is indeed a B channel. So that's pretty nice, it worked. Let's try another one, shall we? So in a real implementation, by the way, you'd make this so that you can now type in another query, but I was too lazy to do that, so I just have to restart the program. So we're going to go to a new channel. Let's do Unbox Therapy. Okay, this is also a channel that is not included in our training data. We're going to go to a program, and we're going to fill in all the data it needs again. Then we can finish by pressing enter, and there you go. The most likely SB score for this query is A. So it was accurate once again. Now I can tell you I've tested this on quite a few YouTube channels, and it's pretty accurate. Lots of YouTube channels, it can actually predict the right score. I think it's about 70 to 80% accurate, so it's actually pretty good. But, of course, it's not interesting to go through, 20 channels right now and prove that it works. It's more interesting to take a look at some of the channels where it gets it wrong. So I've selected some channels where the output is more interesting. So, for example, Tactile. Okay, this is a channel where my program gets it terribly, terribly wrong. And I say that because it underrates it. So we're just going to fill in the data again. And now when I press enter, you'll see that the program gets it wrong. So you can see the most likely SB score for this query is C, not C+. It should really be C+. What I think is the problem here is the amount of training data we used. There simply weren't enough examples to reliably predict the Social Blade score of this channel, because what I suspect is that this is kind of an edge case, and that's the kind of situation where you really start to notice when a training set is too small. So that's probably what's happening here. Another interesting example would be Tom Scott's channel. Okay, so let's go to Tom Scott's YouTube channel now, which is an A- according to Social Blade. We're going to fill that into our program and see what it does now. 1950. So we've typed in the information. I'm going to press enter, and it says no decision made. It's probably something like A-, B+, or B-ish. Now, of course, that's some funny text I programmed in, but what it's basically doing is printing out all the nearest neighbours for this query, because there was no majority. So all of the 3 nearest neighbours, because our program is doing 3 nearest neighbours, like in my example, were different. Therefore, there was no majority, and the program could not decide what the actual query is. So one of them was A-, so if it had picked this nearest neighbour, it would have got it right. And actually, this is our first nearest neighbour. This is the closest match. Okay, so it would have got it right if we were doing 1 nearest neighbour. But because we're using 3, there was no majority, and the program was not able to choose. By picking an amount of nearest neighbours that is larger than the amount of options you have, you make sure that there is always a majority. So if you have 6 options in your classification system, 6 possible outcomes, it's useful to have more than 6 nearest neighbours, because then at least there will be a majority. But of course, in order to be able to use more nearest neighbours, you're also going to need a bigger data set. And that pretty much sums up my little demonstration of the KNN classifier. So as you've been able to see, our KNN classifier wasn't entirely accurate. And that's probably because I didn't use enough training information or example information, because in this case I'm pretty much sure that I used all the relevant statistics, so the amount of features or dimensions wasn't really the problem here. I think the problem was the amount of examples. If we'd used 60 channels as our examples, it might have been a lot more powerful. Anyway, now you know what KNN is and how it works. I hope you've enjoyed this video, and of course, thank you for watching.